Alrighty guys, so in this video, I'm just going to do a bunch of proofs. We're going to try to do some in class, so you might be able to skip ahead. Again, I'll timestamp it all in the Google assignment, so you can jump around wherever you need to go. Okay, so first things first, these ones are all going to be flowchart proofs. So down here, I kind of have the reasons and statements that you might be writing. I'm not really going to use them, but you could use them as sort of a guide to make sure that you have them all taken care of. So, alrighty, let me get my third color here. All right, so this is the process I always go through, and I find it to be very helpful to make sure that you get all the things you need to get in your proof. So in the given, it's stated that PQ is congruent to ST, QR is congruent to TR, and then R is the midpoint of PS. So in my picture, I want to mark all these things down. So because they're telling me that PQ is congruent to ST, PQ, I'll put one tick mark on there because it's a side, and then ST will get one tick mark on there. So those are the same. The next thing that they told me is that QR is congruent to TR. So again, sides, but I can't use one tick mark. I got to use two now. So QR is congruent to TR. And then finally, they told me that R is the midpoint of PS. And what I know is that if R is the midpoint of PS, then that cuts this whole side equally in half. And so these two parts are the same. So I can do 3 and then 3. So looking at my picture here, I can see that I'm going to prove these two triangles congruent by side, side, side. So I set up my squid proof, and in that bullet we put side, side, side. We always have 3 tentacles coming off because we have to state the 3 things that are congruent. So because it was given to me that PQ, or because in my picture, I'm sorry, this is the process I like to use. So I write it down. I got to do it. Because I have in my picture that this orange tick mark is congruent to this orange tick mark, I can say that PQ is congruent to TS, or ST rather. And I was able to put that one tick mark in there because it was given to me. So circle G given. There's no other reason. They just told me those things are equal. Next, in my picture, I marked that QR was congruent to TR because I have those 2 pink tick marks. So I can write down QR is congruent to TR. And I was able to put those pink tick marks in there, again, because it was given to me. They just said, hey, these sides are equal. You're welcome. Okay, and then lastly, in my picture, I marked that PR was congruent to SR, and I was able to put these yellow tick marks in here because I had a midpoint. So let's do this step by step. I can write on my line that PR is congruent to SR because they told me about a midpoint. So because I know the definition of midpoint, I can say that those things are equal. And I knew that I had a midpoint because it was in the given. So circle G given. So you can kind of see like all these things are down here. Now this was initially made for a 2-column proof, which we will try those later. But like we got PQST is congruent, congruent, congruent. We got our side, side, side. We have our given, given, given. And then we have the definition of the midpoint thing right here. So this statement right there isn't really necessary. It's kind of included with that definition of a midpoint. So like it's fine. Now the only thing left to say is that the triangles themselves are congruent. So triangle PQR is congruent. So using our congruent statement, triangle, I'm going to put it down here, triangle STR. So there you go. Alrighty, let's try another. So if they tell me that L is the midpoint of JN, if L is the midpoint of JN, now I know it does not look like it, but I don't base congruency off what the picture looks like, unless it's reflexive or vertical angles. If they tell me that L is the midpoint, it is. So that means it will split this side in half. So this is congruent to that. Then they told me JM is congruent to NM, just because it is. And that's really all they gave you. Which, that's only 2 things, not enough things. You need 3 things. However, looking at my picture, like I mentioned before, you can always get a reflexive shared side or vertical angles if you have them. And so because this side LM is on both triangles, it is congruent to itself initially, or like kind of. I mean, that's basically what we're saying, is that it's congruent to itself. So in my flowchart proof, looking at this picture here, I can tell these 2 triangles are congruent by side, side, side. And so if I write out the first tick marky, we got that JL is congruent to NL. And I was able to do that tick marky there because they told me that L was the midpoint. So because I understand the definition of a midpoint, I can write that those things are congruent. And I knew that I had a midpoint because it was circle G given to me. I also need another side. So in my picture, I marked the pink sides next. So JM is congruent to NM. And I was able to put those pink tick marks on there because they told me those sides were congruent. They just are. It was given to me. Now the last side that I marked is that LM on the right, or on the left triangle, is congruent to itself on the right triangle because it's on both. So like LM is congruent to LM. And that's the reflexive property. And I knew I had a shared reflexive thing because I looked at the circle P picture. So again, then I got to say the triangles are congruent. So triangle JLM is congruent to triangle NLM. And so we kind of have all those things down here. We got our side, 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 side. We have our given, given. And like, we didn't really have to say picture, but they have that reflexive property there. We got our definition of a midpoint. This is that extra thing. And we got our congruent statement. So we got it all. Alrighty, let's try some more. It is given that X is the midpoint of VZ. So I'm going to go mark that right now. If X is the midpoint of VZ, that's cutting this in half. So these 2 sides are the same. It's also given to me that X is the midpoint of WY. So WY, X is the midpoint, cuts that guy equally in half. 2 tick markies this time. I don't know if they're the same as the first one. That's all they gave you. And that's only 2 things. I always need 3 things. So again, if I take a look at my picture, I can look for a reflexive shared side or vertical angles, which I think is what I have this time. At X, we have 2 lines crossing. And so this angle would be congruent to that one. And so I can prove the 2 triangles are congruent by side, angle, side. So SAS. And I know that my first side was congruent. So BX was congruent to ZX. Like I was able to put those orange tick markies on there. Because they said I had a midpoint. So by definition of midpoint, and I knew I had a midpoint because it was in the given. Next, I have that this side of X is congruent to that side of X, and so I really have to name it with 3 letters. So like angle BXW is congruent to angle ZXY. And I was able to put those yellow rainbows in there, not from anything in the given, but because I had vertical angles in my circle P picture. And then last but not least, I was able to mark that the 2 tick markies, these sides are congruent. So WX is congruent to YX. And I was able to put those on there because I had a midpoint. So definition of midpoint. And I knew I had a midpoint because it was circle G given to me. And so triangle BWX is congruent to triangle ZYX. And again, we got all the things on there. Don't worry about it. Okay, another one to try. First thing that's given to me is that XW is congruent to XY. The next thing that they gave to me is that XZ, this line here, is bisecting WXY. So it's cutting X in half. So if a line is cutting an angle in half, we have an angle bisector. So we talked about that on our hint page, I think 42, 30 something, 40, yeah, 41. No, yes, 41. But that just means, so this is cutting that angle in half. This angle is congruent to that one. So like the 2 sides were split equally in half. And that's all they gave you, which is only 2 things. You need 3 things. But if I take a look at my picture, again, I have this shared side. I don't have vertical angles, but I got this shared side. So I can mark that XZ is congruent to itself. I didn't need to put 3 tick marks on it, but I did. I don't know why. Anyways. Alrighty, so we're going to prove this triangle congruent by side, angle, side, because we got these 2 sides surrounding this angle here, so side, angle, side. And again, from my picture, I have that WX is congruent to YX, and I was able to put those orange tick markies on there because it was circle G given to me. The angle that I marked is that angle, and I can't just call it X. There's kind of a lot of angles happening at X, so I got to call it with 3 letters. WXZ is congruent to angle YXZ. Okay. And I was able to mark that those were congruent because I understand what a bisector does. So by definition of bisector, and I knew that I had a bisector because it was in my given. And I think down here, angle bisector, maybe a little bit more specific, but it's fine. And then last but not least, we marked accidentally 3 tick markies, but that XZ is congruent to XZ. And we were able to do that because we looked at that picture and we had a shared reflexive side, so that reflexive property. And I could tell because it was in my picture. So triangle WXZ is congruent to triangle YXZ. Alrighty. Hopefully we're getting the idea here. I know it seems like a lot, but we actually only have 4 more, so we're halfway through. Alrighty. So angle, side, angle, proof number 1. If we take a look at this first piece of given information, it says that QR is bisecting. Ooh, my letters got erased. This guy over here is P and that guy is S. E. So QR is bisecting PQS. So this line is cutting this angle in half. So this side of the angle and that side of the angle would be congruent. I'm also given that angle PRQ is congruent to angle SRQ. But that's only 2 things. I need 3 things. I only got 2 things. So if that happens, you got to take a look at your picture and hope for a shared side or angle or vertical angles. And in this case, I really do need a side because angle, angle, angle wouldn't work. And luckily we have this side right here, QR, that is on both triangles. So it is congruent to itself on each one. So I can say that this triangle is congruent to that one by angle, side angle, because we got the two angles surrounding the one side. So angle, side angle. So always three tentacles, because we always have three things going in, like three things that we need to show congruent because it takes three to use a shortcut. And so the first angle that I marked was the orange one. And so I can say the angle PQR is congruent to angle SQR. And I was able to put those orange rainbows on there because I understand the definition of a bisector. So bisector. And I knew that I had a bisector because it was circle G given to me. The next thing that I wrote down, or the next thing I could write down rather, is a side, even though that wasn't the next thing I marked. But if we go in order of our shortcut, the side that I marked here is that QR is congruent to QR. And guys, you don't really have to go in that order. I just like to because in my brain it makes sense. And I was able to write that QR is congruent to QR because it is a shared reflexive thing. So the reflexive property. And I knew that I had that because my picture showed me. And then lastly, my other angle was that angle PRQ was congruent to angle SRQ, the pink angles here. And I knew so because they told me so. There's no other reason. It was just given to me. So that's nice. So we can say that triangle PQR is congruent to triangle SQR. On to the next. Okay, we're getting a little more interesting here, more bisecty stuff. So in this one, it is given to me that AC bisects angle BAD. So AC is bisecting angle BAD. So on A, we are getting cut in half. And I always kind of put them like off like of each other like that, so it doesn't look like I'm talking about all of A. This shows me I'm talking about the top one and then the bottom one. So I always kind of put them a little off kilter like that. Then we got AC, so same line, is bisecting BCD. So over here at C now, cutting in half. So two rainbows and two rainbows. And that's it. Just two things, but I need three things. Two, three. So hopefully my picture will get me something like vertical angles, although again, that wouldn't work because angle is not a thing. So hopefully we got a shared reflexive side, and we sure do. So I can mark that AC is congruent to itself because it's on both triangles. So to prove these two triangles congruent, by looking at my tick marks and rainbows, I have a side with the two angles around it. So that is why it's angle, side, angle. On my little squid lineies, I'm going to write the first angle that I marked, which was angle BAC, is congruent to angle DAC. And I knew that those orange angles were going to be congruent because I understand the definition of a bisector. And guys, it's really okay if you just put bisector. We can be a little lazy. It's all right. This is how I usually go about proofs. Get it done. And I knew I had a bisector because it was circle G given to me. Next, the side that I marked in my picture is that AC is congruent to itself. And I know so because it was shared, which is that reflexive property thing that I could see in my circle P picture. And then lastly, my other angle, my pink angles here, angle BCA is congruent to angle DCA, the pink angles. And I was able to mark that those pink angles were congruent because they told me I had a bisector. in the circle G given. So therefore, triangle BAC is congruent to triangle DAC. Love it. Okay. Last two. I know there are more pages. We'll come back to those actually later. So no worries. These are the last two. Alrighty. So now remember, you don't have to watch this whole video if you don't need to. It is for circle G given to me that SR is bisecting this angle. So cutting the angle in half at S. So boop, boop. Then they gave to me that angle SQR, so SQR, I feel like I could have just called that Q, is congruent to angle STR. Again, I feel like I could have just called that angle T. But that's all they gave to me, and that's only two things. I need three things. And a third angle won't help because angle is not a shortcut you can use. So hopefully in my picture, I can get a shared reflexive thing. You couldn't get like a midpoint thing because that would have to be in the given, or like a side bisector, like that have to be in the given. And it sure isn't. So like it has to be a reflexive thing. And luckily right here, we got one. So in my flowchart proof, this one is not angle side angle because like these two angles, it's not the side that's marked in between them. The side that's marked is kind of only on one of those angles. So that's why we call it angle side. You could also really call it side angle. But it's just like I can't have the side in the middle of the two angles because it sure isn't. On my squiddy proof, we're still going to have our three lines because we got to have our angle, and then our side. So the first angle that I marked were the orange ones. So angle QSR is congruent to angle TSR. And I was able to mark those orange angles congruent because I had a bisector in the circle G given. The next thing I want to write down are my other angles, so the pink angles, which, I mean, I'm just going to call it Q and T. Angle Q is congruent to angle T. There is no confusion. Like, there aren't multiple angles over there, so I'm just going to call them that. And I was able to mark that those pink angles were congruent because they told me so in the circle G given. And then I want to say that the sides are congruent. So the sides that I have are SR is congruent to SR. And I know so because they are a shared reflexive thing in the circle P picture. So that means triangle QSR is congruent to triangle TSR. Last one. You got this. Hopefully you feel so good about proofs. Okay. It is given to me that XWZ is congruent to angle XYZ, so XWZ. I feel like I could have just called that W. And then XYZ, could have just called that Y. Those boys congruent. Then they told me that XZ bisects angle WXY. So this is cutting X in half equally. That's only two things. I need three things. So I got to get a third thing, hopefully, from my picture. Hopefully a side, because angle won't work. And luckily, we have this shared side in the middle, which again is a reflexive property thing. So we got going on here. Angle, side. Again, not angle, side, angle, because that side is not in between the two angles that I have. Like, that is not the one that's marked. So that's why we call it angle, side. Or side, angle if you really want. Three tentacle lines. First thing I said was that angle W was congruent to angle Y. And again, I really didn't need all the rest of the letters. And I was able to say that because it was circle G given to me. The next angle that I marked, I do need to use three letters there because there's kind of a lot going on at X. So angle WXZ So WXZ is congruent to angle YXZ. And I was able to put those pink rainbows on there because they told me I had a bisector in the circle G given. And then the last thing I marked was this side here. And so XZ is congruent to itself because I noticed a shared reflexive property in the circle P picture. So therefore I can say that triangle XWZ is congruent to triangle XYZ. Triangle proofs. I love them. And I love flowchart proofs.